In this lesson, we will be working with scaffold actions, icons and much more. For that, we will be using the reference of our completed project. So let me bring up the design. And here you can see that we have two icons, the drawer icon and the plus icon. Now we'll work on this drawer icon later, but first let's focus on this plus icon. So anything that you see at the right hand side of this scaffold is controlled by the action argument. So let's move into our code. So let's move into this main screen, and inside of this F bar we have an argument called actions, and this action will have a list of widgets like the child in the column. Alright. So inside of this action I'll be placing an icon, a plus icon. So let's learn how we can use icons in Flutter app. So for using the icon we must use the icon widget. So icon. So this icon widget has different arguments that can be passed, but the first argument icon data is the important one, which is an actual icon. So type icons data and then dot, and you will get all of these icon suggestions that you can use. So we are trying to add the plus icon over here, so it is probably add. So there is a website with the list of all of these material icon, but the best and the fastest way is to guess the icon. So if I wanted add, then I'll be guessing add. If I want camera, then guessing the camera will sometime bring up the result. Alright. And if it does not, we have a website for the reference. But first let's change this camera back to add, so that we have a add icon in our scaffold. So here you can see we have this add icon over here. So inside of these actions, if you keep multiple widgets, let me copy and paste this over here. Change this to camera. Then our scaffold will automatically align the widgets in an horizontal order at the right side. Alright. So let's remove this icon. And now let's explore other options that are available to us. So for instance, if you want to change the color, then you can use this color argument. So if I keep this to colors.red, then my icon will be changed to red color. Alright. So the other argument that you can use is the size argument that will define the size for this icon. By setting the size to 45, my icon is now 45 pixels. So if you want a list of material icon that you can use over here, then you can search for material icons list for Flutter and navigate into this API documentation. Once you are here, scroll below and you will get the list of all the icons that can be used. You can also find a specific icon by pressing Ctrl F and then searching for the icon. If I am searching for camera, then I can get the camera results. Alright. But my personal preference is this feather icon for Flutter apps. It is an open source icon library and it has way many options than material icons. Alright. So for using these icons, you can search for feather icon Flutter and you can navigate into this pub.dev website, click at installing and install this package in our Flutter project. So now let's install it and hard restart our application. Alright. Once the app has restarted, let's import this feather icon over here. So import package and then the feather icon / feather icons.dart. Alright. Now let's use it over here. So instead of this icons.add, let's replace it by feather icons dot and then the icon name. So in my case it will be a camera. So let's save it. And here you can see that we have this camera over here from the feather icon. Alright. But in our original app we have this plus icon over here. So let's replace this with icons.add. Let's keep it simple for now. And also let's remove this import as we are no longer using it. So if you look at this icon, there is no spacing in the right side. It's sticking to the right side. So let's wrap it with a container that has a padding. Now if you want only the padding and not the margin or the background color, you can simply opt out of using this container and use this padding widget. Alright. This will automatically provide the padding without the need of the container. So here we have this plus icon with a beautiful padding. Alright. So let's move to the drawer component. So for this drawer icon, you don't need to create the icon like this plus icon. Instead, you can use the drawer argument of scaffold. So inside of this scaffold, we have an argument called drawer, which expects a widget called drawer. Alright. So without using any argument of the drawer, let's save our code. And here you can see that the drawer icon has automatically appeared in our scaffold. And if I click this icon, a drawer will appear. Alright. So now we need some data inside of this drawer. So let's use this child argument. And this child argument will expect a widget. So let me pass this text widget with a text called drawer data. Alright. So let's save it. And here you can see that I have this drawer data as a child of the drawer. So let's leave this drawer as it is for now, and we'll be modifying this later. For now, let's focus on other important stuffs. So at the original design, when you clicked this plus icon, a bottom sheet used to appear, and this bottom sheet was triggered when a user clicked at this plus icon, right? So how can a user interact with the UI component that is not a button? So far we have only learned about the elevated text and outline button for the user interactivity. But now we will be extending our interactive elements further by using inkwell and gesture detection. Alright, so that will be the topic for the next lesson. So I'll see you there. In this lesson, we'll be working on making our UI components interactive. Meaning that without using buttons, we'll make our UI component respond to touch or clicks. This is important because we cannot use buttons everywhere in our UI. This will mess up our design. So instead of using buttons, we'll make this UI component respond to user touch or clicks. Say for instance, if you want this plus icon to respond to user touch, then replacing it with a button might not be a suitable option. So instead we'll be using the same widget, but we'll be wrapping it with another widget that has the interactive feature so that whole components become interactive. Alright, so let's see that widget in action. Now we need to turn this plus icon into an interactive element. So let's wrap this icon widget with our special widget. So wrap it with a widget, and this widget is called a gesture detector. Alright, and this gesture detector has an argument called onTap that is responsible for turning this widget into an interactive element. So in this onTap argument, we have this anonymous function like we had previously in onPressed of our buttons. So inside of this onTap, let me type this print so that we can see the output in the debug console. So print, and the plus icon is clicked. Alright, so let's save our code. So let me collapse this so we can see this debug console better. So now if I click at this plus icon, you can see that the plus icon is clicked, has been printed in our debug console, meaning that our plus icon has turned into an interactive element. This gesture detector widget can turn any widget into an interactive element, whether it be text, image, or any widget. So let me create a body argument inside of this scaffold. So body, and let me create a text widget over here. Now I can wrap this text widget with a gesture detector to detect taps on this text. Alright, so the gesture detector, and main thing that we need inside of this gesture detector is the onTap argument. And inside of this onTap anonymous function, let me print clicked over here. So now if I click at this text widget over here, then you can see that I have this click displayed in my debug console. Alright, so we are able to convert this text widget into an interactive element. But this click of this gesture detector is little bit different than the click of a button. When you click at the button, you get a kind of a ripple effect. You can feel that the button is being clicked, but this gesture detector is not able to provide visual feedback like the button. So I am clicking at this text, and you can see that the function is also running, but I am not feeling as if this text is being clicked. Alright, because I am not getting any visual feedback. Now if you want a visual feedback on your widget, then instead of using this gesture detector, you can use inkwell. This inkwell provides a material design visual feedback. So if I click at this text, you can see that I am getting a kind of a ripple effect, and I am feeling that this text is being clicked. And this inkwell is similar to gesture detector. It also has this onTap argument as the child argument, and it provides a visual feedback. So why did we learn this gesture detector in the first place? And this is because this gesture detector widget is widely used in Flutter for detecting complex gestures like pinch gesture, swipe gesture, and so on. And you'll often see this gesture detector being used for this on-tap detection as well, so it's better to know. Alright, but if we only want the functionality of on-tap, on double tap and such, we can use this inkwell. So in this plus icon, we cannot get any visual feedback, so let's replace this gesture detector with the inkwell. Now if I click at this plus icon, I can feel that this icon is being clicked. Alright, now instead of just wrapping this icon with an inkwell, let me remove this widget and let's wrap this overall padding. So wrap with an widget, and the widget name is inkwell. Alright, and now if you do not provide on-tap argument to an inkwell, then the ripple effect will not occur because it is not being clicked, right? So for this to work, you need to provide the on-tap argument. So let's provide an on-tap argument to this inkwell. So on-tap anonymous function, and inside of it, let's just print OK. Alright, now let's save our code. Now if I click at this plus icon, then you can see that my inkwell is covering all of the padding, and all of this padding is giving me a ripple effect. Alright, now you can also customize the effect of this inkwell, like changing the color of this splash. So for that you need to tap into this splash color argument and then provide the color. So if I provide this green color, I'll be getting a green splash. Alright, now if you don't want a splash in this inkwell, then you can simply replace this splash color with colors.transparent. So now if I click at this plus icon, I get no splash effect, but you can still see this gray area if I long press this button. And if you want to replace that, or if you want to disable that as well, you can tap into this highlight color and replace it with colors.transparent. Alright, and now if you click at this, you will no longer get any visual feedback, but you might still be hearing some sound in your emulator, a haptic feedback kind of sound. So if you want to disable that as well, you can tap into this enable feedback and turn it to false. Alright, so now I'll not be getting any visual or audio feedback if I click this button. So it's basically turned into a gesture detector. So in this plus icon we need a feedback, so let's remove all of this, and now we can get this visual and audio feedback from this inkwell. Alright, in our completed app, when this plus icon was clicked, a bottom sheet used to appear. So let's create our first button sheet. Now inside of this on tap, instead of printing OK, I'll be showing a bottom sheet. So use this show model bottom sheet provided by Flutter, and this context is the context of our build. And inside of this builder, we'll have a parenthesis and we'll be providing a context over here. And inside of this, we have a curly braces, and this builder function should return a widget. So return and then a widget of any kind. So I'm returning in container over here. Let's close this within semicolon. Let's save our code. Now if I click at this plus icon, you can see the bottom sheet has appeared in our app. You can also customize this bottom sheet as per the requirement. So if you want the background color, tap into this background color argument and then colors.red. Now for seeing the changes in this bottom sheet, you need to reopen this bottom sheet. So let's close this by clicking outside and then click at the button, and you can see the updated bottom sheet. Now this height of bottom sheet will adjust automatically according to the child height placed inside of this bottom sheet. So if I change this return container to something like a text widget, then this bottom sheet will be resized to meet only the text height. So if I click this plus icon, you can see that height has been adjusted according to the child height. So let's replace it with a container. While using this container, bottom sheet will automatically take 50% of the screen, but we can change the size of this bottom sheet by declaring the size of the container. So if I keep it to 100, then my bottom sheet will also be resized to 100 pixels. Alright, so 100 pixels seems a bit low, so let's change it to 250. Let's save our code, and that seems about alright. So now let's change this background color to white, or let's remove this. So now we have a perfect looking bottom sheet and a drawer. Alright, now in the next lesson we'll be working with text controller and input elements in Flutter. So I'll see you at the next lesson. In this lesson we'll be working with text field in Flutter. So for allowing our users to enter the to-do tasks, we must provide a text field in which a user can type their task. So for that we need a text field. So let's create one. So instead of using this main screen, let's create a new file with the name add-todo.dart. So we created this new file because in Flutter we always want our code to be minimal so that it's maintainable. Alright, so inside of this add-todo.dart, let's create a stateful widget. And now let's rename this widget to add-todo. And now let's replace this placeholder with a text widget with the text add-todo, and import this text widget from material.dart. Alright, so now let's use this class in our main screen.dart. So instead of this some text, we'll be using our custom widget. And now let's import this as well. Alright, so now let's move into this class and wrap this text widget within column so that our text widget and text field widget are aligned in a vertical order. So for creating a text field, we will be using the text field widget. So type text field, and without any argument, let's save this. So here you can see that we have a text widget in our UI, and inside of this text field I can type anything. So let me type a simple task. So after I am done with typing, I need a button over here which will add this task to my to-do list. So let's create an elevated button right below this text field. So elevated button, and inside of it, in our onPressed, we will be providing an anonymous function, and child will be the text widget. Alright, so here we have the add button. So whenever I click this add button, I want the value from inside of this text field. And my primary task is to take this text view value and print it in my debug console. Once I'm able to get this in the debug console, I can do anything with that data. Alright. So for getting the value inside of this text field or modifying the data of this text field, we need a special type of class which is called a text editing controller. So text editing controller, and let the variable name be toDoText, which is an instance of text editing controller class. Alright. So now by using this text editing controller, we can get the data of this text field or manipulate the value inside of it. So for that we need to assign this text editing controller as a controller of this text field. So press Ctrl and space, and we have this controller argument, and in this argument we will be passing this toDoText. Alright. So the text field is now synced with the controller. So now by using this toDoText, we can get the value of this text field. So let's move inside of this onPressed method of elevated button, and let's try printing this toDoText.text. Now using this .text, we are able to get the text value of this toDoText. So if I type hello in this text field and click at this add button, then you can see this hello is being printed in my debug console. I can also use this text editing controller for manipulating the value. So if I set this toDoText.text to an empty string, and if I click at this add button, then this hello text will be printed in my debug console and the text field will be cleared. Alright. So this text editing controller helps us to get the value and manipulate the value of the text field. We can also customize this text field. So let's explore some of the options that are available for the text field widget. Alright. So if you want a placeholder over in our text field, then you can tap into this decoration argument which expects the input decoration. And now by pressing Ctrl and space, you can see all of these arguments that can be passed over here. Now if you want a placeholder, then we need the hint text argument. So hint text and the placeholder text. Alright. So here is the placeholder in our text field. So if you want a label in this text field, you can use this label text argument in input decoration for providing the label for your text field. Say for instance, this input field is for the username. So if I provide username as the label text, a label will appear above the text field. Alright. So now if I want an icon in my text field, then I can use the icon argument of this input decoration. So icon, and we can pass an icon over here. So this will bring up a properly aligned icon in our text field. Alright. So let me type something over here. So you can also provide styling to the text inside of this text field. For that we will be using the style argument. So style, and this expects a text style like in the text widget. So text style, and inside of this text style you can use all of the argument that you previously used in the text styling of a text widget. So if I want the text to be bold, then I can use this font weight.bold, and this will make my text bold in the text field. If I want to change the color of this text, then I can use this color property, and I can change the color. Alright. So if you want internal padding inside of this text field, then you can use the content padding property of this input decoration. So content padding, this content padding will expect a edge insets. So edge insets dot all, and let's provide 5 pixels from all sides. Alright. So in our case we don't need all of these decorations, so let's remove them. Let's remove the label text, icon, and the text styling as well. Alright. So let's save our code. So now we have a simple text field, and now let's move this add to do widget inside of the bottom sheet. Alright. So we'll take this content and keep it inside of our bottom sheet. So let's navigate into our main screen. So currently we have this add to do in the body of a scaffold. Now instead of this add to do, let's replace it with a container. And now let's move this add to do inside of our show model bottom sheet. So let's keep that add to do as a child of this container. Alright. So child, and then the add to do. So now this add to do is placed inside of this container in the bottom sheet. So let's provide some padding in our container. So to see the changes in our bottom sheet, we need to reopen this bottom sheet. So let's close it and open it again. So here's the padding. So now let's decrease the height of a container so that our bottom sheet height gets decreased. Alright. So 200, and let's reopen it again. So it seems about alright now. So that's it for this lesson. In the next lesson we will be working with advanced child to parent communication. So I'll see you at the next lesson. In this lesson, we will be working on advanced child to parent communication. We will not only communicate with the parent through the child, but we will also be passing the data from the child to the parent. Alright. So in our previous project, the billionaire app, we had a button in our screen, and when the button was clicked, the main screen data was updated, right? So it was a simple case of child to parent communication. There was nothing but a simple click being transferred from the child to the parent. But in this lesson, we will be learning a little bit advanced version of it. Alright, so let's get started. So now let's start with the basic child to parent communication first, and then we will move to advanced version. So inside of this scaffold body and inside of this container, let me create a text widget with the text simple text. Alright, so my initial goal is to change the text widget whenever this add button is clicked from inside of this bottom sheet. Alright, so I want to change this text when this add button is clicked. So now let's create a function for changing the text. So let the function name be change text, and we are trying to change this text. So instead of hard coding our text, we need to create a variable for it. So string text equals to simple text. Alright, so now let's replace this text in our text widget. So instead of simple text, we will be providing this dynamic text over here. So whenever this change text function is called, I want this text variable to be updated and also notify the state about it. So let's use set state and update the text value inside of it. So now we need to figure out a way to call this change text by the button that is inside of this bottom sheet. Alright, so this is a very basic instance of child to parent communication, in which we are only trying to execute the function that is inside of this parent through the child. So let's move into this add to do dot and let's create a void function over here. So void function, and the function name will be change text. Alright, so now let's pass this function to the constructor. So required this dot change text, and now let's remove this const as well. So now let's call this function from inside of our elevated button on pressed. So let's keep it over here. So whenever we are working with an stateful widget, we cannot directly access the property of this class inside of this state class. Alright, so for doing that, we need to use this widget dot and then the property name. So in the stateless widget, we can directly access the property of the class because it has only one class, right? But in stateful widget, as it has two classes, we need to use this widget dot. Alright, so now let's move into our main screen dot and pass the function that we just created. So change text is the change text function inside of this dot file. So here you can see there are some errors in my debug console, but in my dart file there is no error. So hot restart should probably fix this. Alright, so let's hot restart our app. So whenever you get an error on this debug console, you might need to hot restart it multiple times. So seems like it's fixed now. So if I click at this add button, you can see this text is being changed. So this is a simple example of child to parent communication. Now let's move to the advanced stuff. So before doing that, let's fix a minor issue in our app. So whenever you click at this text field, you can see that the entire bottom sheet has been hidden or covered by this keyboard. So let's fix that now. So whenever this keyboard pops up in our screen, our app screen size decreases. So in order to show this bottom sheet clearly, we need to provide the padding of this keyboard, or the height of this keyboard is the padding of the bottom sheet. So for doing that, let's wrap this container within padding. So let's wrap it up. So here, instead of using this as inserts.all, what we will do is we will figure out the height of the keyboard or the available screen space by using media query dot of, meaning the context of this builder, and then dot view inserts. By doing this, our bottom sheet will automatically have the padding according to the height of this keyboard. Alright, so let's save our code. And now let's open the bottom sheet again, and now if I click at this, my bottom sheet will automatically add the height of this keyboard as a padding. Alright, so now let's move into the advanced stuff. So let me write something in the text field over here. So my goal is whenever I click at this add button, the text inside of this text field need to change the value of this text widget. So how can this be done? Currently we are only executing the function of the parent by using the child, but now I also need to pass the data instead of just calling the function. Alright, so how can this be done? So let's move into this add to do dot, and here you can see that we are only using this void function without any parameters. So by using the parameter, we can communicate or send data to the parent. So as I'm trying to send a string over to the parent component, I'll be creating a string parameter called to do text and make it a required field. Alright, so now as it is a required field, I need to pass this argument over here. So to do text equals to do text dot text, the text that is inside of our text field. Alright, And now we need to take this text clearing part and move it right below this function so that we do not pass the empty string to our change text function. Alright. So let's save up our code and navigate into this main screen.dart. And in this main screen.dart we have a problem in our change text function. This problem has occurred because previously in our change text function we did not had any parameters, but now in our add_to_do.dart we have a required parameter called string or the to do text string, right? So we need to change this function in our main or the parent to have this required field as the parameter. So required string and then the to do text. So now let's change this text from hello world to do text. Alright, so $to do text. So now if I save the changes and reopen my bottom sheet and type something in my text field and click at the button, you can see the content of the text widget is being changed. So this is how you not only call the function but also pass the data while calling the function from child to the parent. So now the child can send the data into the parent and the parent can change data accordingly. Alright. But in our current scenario, there is only one text widget in to-do app, but we can have multiple to-do data or multiple to-do list in our to-do app, right? So how can we handle multiple data or multiple list of data? For that, we need to understand lists in Dart. So in the next lesson, we will be understanding lists and map in Dart. These are advanced data types that we need to understand for creating advanced apps. So I'll see you at the next lesson. In this lesson, we'll be working with lists in Dart. So what are lists exactly? So lists are the collection of data, meaning that if I want to create a single fruit, I will create a string fruit equals to apple, alright? But if I want multiple fruit, say a basket of fruits, then I'll be creating a list. So this is how you create a list in Dart. So you start by typing list, which is a data type, and then the angle brackets. And inside of this angle bracket, you want to define the data type of the collection. Say if you want this list to be a collection of string, then you can type string over here. If you want it to be a collection of number, you can type double, num or integer over here, alright? But for now, we are creating a list of fruits, so string it is. So now you need to define the list name. As you are trying to create a list of fruits, my list name will be fruits. So it is a list of fruits, alright? And the value of this list is always enclosed by these big brackets. And inside of this, you can have the collection of the data type that you have defined. In our case, is string, alright? So apple, orange, banana, and so on. So this is the list or the collection of fruits. So inside of this list, we can only include the strings because it is a list of strings, right? If I change this to an integer, I'll be getting an error, and this is because a string can be assigned to an integer, alright? So for this, I need to change my values to integer. But if you keep the collection data type as dynamic, then you can include anything in your list. You can include number, string, booleans, and so on. Alright. So now that we have a basic idea of what lists are, I want to show you something. So without even understanding the concept of list, we are already using the list in our billionaire app. So if you look into this column widget, it has an argument called children, and if you hover at it, you can see that children is actually a list of widgets. And as this list only expects a widget as a children, we cannot provide anything but widget inside of it. So we have text widget, size box, and so on, right? And here you can see that the children value is enclosed by this big braces. So whenever you see big braces in Flutter, it means it is a list, alright? And there can be multiple data inside of it. So without even understanding the concept, we are using list in our Flutter project. So now that we have a basic understanding of list, let's explore what else can be done with the list. So now let's create a list that is relevant with our to-do app. So let's remove this and list. And as the to-do list is a collection of strings, so data type will be the string, and then the variable name will be to-do list, and it will be enclosed by big brackets, and inside of it we will have the list of to-do items, alright? Now there are different things that you can do with a list, for instance looping the list, getting the length, and so on. So let's create an entry point, so void main, and let's keep this list inside of this main function, alright? And now if I print this to-do list dot length, then I'll be getting the count of the items that are inside of this list. In my case, there are 3 items, so I'll be getting the result 3, alright? Now if I add another string to it, I'll be getting the result 4. So there is one important thing that you need to understand while working with list is the indexes of the list. Indexes define where a particular data is situated in a list, alright? So this bath is of index 0, this brush teeth is of index 1, it is of 2, and this is of 3. These indexes define where the data are situated inside of the list. Alright, and the index always start within 0. You need to keep that in mind. Alright, so if I want to get this brush teeth data, which is of index 1, then I need to type list name and then the big brackets, and inside of it the index. So if I want to get the brush teeth, I'll be keeping 1 over here and run this, and I'll be getting the data in the first index. By using the indexes in list, I can also modify the data. Say for example, if I want to change the data of the first index, then I can change it like so. So now if I run this, then the second index data has been changed to monkey. Alright, now if I print this whole list instead of this only one item, then I get this modified result. Let me remove this, and if I run this, then you can see that the first index data has been changed to monkey. So this is how you set and get data from the list. So now let's clear this up so we have a nice list to work with. So now let's explore what else can be done. So if you want to add a new element into this list, then you can use the add functionality of the list. So if I want to add a new item over here, I can write to-do list.add, and I can simply add an item to the list. Alright, and I can use this add multiple times for adding multiple items into the list. So if I want to add another component, then I can use to-do list.add and provide another item. But there is a better way for inserting or adding multiple items to the list. Instead of writing in this way, you can simply use the add all functionality and pass the list to be added inside of a list. So if you replace this with add all, then this will expect a list inside of it. This can have multiple components or multiple elements inside of it, and if you provide these multiple elements, this list will get attached with the to-do list. So add for the single component and add all for the multiple components. Alright, now if I want to add an element in my list in any specific index, then I can use this insert functionality. For instance, to-do list.insert, and if I want this value to be at the first index or the 0 index, then I'll be providing the index number and then the items to be written in that index. And in this way I can add some items at a particular index. Now there are different other things that you can do with the list. Now if you want the first element, then you can write to-do list.first, and this will provide you with the element of the first index. In our case it is read books because we have modified this list. So we got this read book. If you want the last element, then you can write last, and it will provide the last index element. If you want to check whether this list is empty or not, then you can use this to-do list.isEmpty. Then this will provide the response in a boolean, meaning true or false, and you can see whether list is empty or not. Alright, and now if you want to reverse this list, then you can use this dot reversed in our list. So by doing this dot reverse, we will get the result in a reversed order. Alright, not only adding and inserting, we can also remove the elements from our list. So let's remove this reversed and make it an original list. So for removing the element, we can use the remove functionality and pass the value that needs to be removed from the list. So if I want to remove this brush teeth, I need to provide this value over in my remove function, and this data will be removed from our list. Alright, so this dot remove will expect the value that needs to be removed, but you can also use indexes for removing the value. For using the index, you need to use the functionality of remove at, and then you can provide the index that needs to be removed. So remove at 0 will remove this bath from our list. Alright, so if I run this code, then this bath will be removed from the list. Alright, so this is how we use lists in Dart. Alright, so we learned about how list is created, how we can use the list, how we can get the data from the list, remove the data, insert data, and so on. So whatever we learned about list up to this point are the basic stuffs. There is obviously more to learn. So the main goal of this lesson was to make you understand what lists are and how to use them in a basic manner. So there are other different things that you can do with the list, but due to time restriction, I will not be able to provide all of them. So when time comes, you will be learning that eventually. Alright, so that's it for this lesson, and in the next lesson we will be using this list in our to-do app. So I'll see you at the next lesson.